Video 5-2A by myself, Adam George. Let's imagine there's a farmer and he grows lake trouts for a living. In his lake, the average or mean weight of the adult lake trout is 40 pounds. There's a standard deviation of 10 pounds. He wants to increase the average size of his lake trout, so he wants to reproduce only the top 10%. This 10% cutoff is called the truncation point. It can be any percent, but for this situation, it's 10%. We also know that the realized heritability is 0.67. To find the truncation point, we take the average or mean of the original population and add z times our standard deviation. We can get z from this chart. Our proportion selected is 10%, or 0.1, so our z is 1.282. Here we take our average, which is 40 pounds, and add it with our z times our standard deviation, which is 10 pounds, to give us 52.82 pounds, which is the truncation point. Our selectional difference, or S, is the difference between the average of our selected fish minus the average of the total population. For this, we multiply I times the standard deviation. We can get I from this chart again, which is 1.755. 1.755 times 10 is 17.55. Now we're trying to find R, which is the response from the selection. This is equivalent to the average of the offspring minus the average of the original population. This, we take our realized heritability, which we learned earlier, times our S, which we got from the last slide. That was 17.55. 0.67 times 17.55 is 11.7585. The mean of the selected parents is simply our original average plus our selectional difference. This would be 40 plus 17.55, which is 57.55 pounds. Our mean of the offspring is just as simple. It's the average of our original population plus our response to selection. This is 40 plus 11.7585, which is 51.7585 pounds. So here's the graph showing it all together. The blue is the original population, the orange is the offspring population, and the green is our selected population. We see here that our 40 pounds average is with the original population, and our 57.55 pounds for the selected population, and then our offspring population has an average of 51.7585 pounds. The truncation point is also shown here at 52.82 pounds. This means that anything past it was within that top 10%. Our R here is just the difference between the 51.7585, the average of the offspring, minus the average of our original population, which is 11.7585. And then our S is the selected population minus the original population averages, which is 17.55 pounds. Just as a note, the value locations in this image are not exactly to scale, but it still gives a good representation. These are my citations. Thank you.